Good morning, everyone. So, today we will be discussing problems based on week 9 content. On Wednesday, we discussed some a revision of some of the things of Fourier series, then the Fourier transform definition, properties including duality, and convolution. Before we start, can someone please confirm whether am I audible and my screen is visible?
Yes, ma'am. Audible and visible.
All right, thank you. So, let us begin. Initially, we have some very easy problems and it has some certain parts. So maybe I will solve the first one and then the next one, which is similar, I will give that to you. So let us start now. First question. So you have this A part, first question A part. You have this signal xt is equal to e raised to the power of minus at ut. A is greater than 0. You have to find the Fourier transform of xt. I will solve this one, then the next one I will give it to you so that you know how to do it. So we know by the definition of Fourier transform that the Fourier transform is equal to integration from minus infinity to infinity xt e raised to the power of minus j omega t dt. This is the definition of the Fourier transform. What we will do now is, instead of xt, we will substitute the one given in the question. So let us do it. Integration minus infinity to infinity e raised to the power of minus at ut e raised to the power of minus j omega t dt. So because of ut, can someone tell me what will the limits of integration be if I remove ut from here? What will be the effect on the limits of integration?
Zero to
Zero
infinity.
to infinity.
Yes, that's correct. Because ut is 1 in 0 to infinity and otherwise it is 0. So I will write 0 to infinity e raised to the power of minus at minus j omega t dt. Now we will just take these both e terms together and then compute the integral. E raised to the power of minus a plus j omega inside bracket into t dt. We compute the integral, so it will be following. And these are my limits. So when I substitute the upper limit, that is t equal to infinity, it will become e raised to the power of minus infinity. So that will be 0. Then next I substitute t equal to 0. That becomes e raised to the power of 0. That is 1. And the sign, because of lower limit, and this one will make it positive. Minus minus plus. So plus 1 upon a plus j omega. So we get the Fourier transform of e raised to the power of minus a tut, a greater than 0. The Fourier transform comes out to be 1 upon a plus j omega. So this was the first part. Is this clear? How we computed?
Yes, ma'am.
Okay, now B part you have to do. It is just very similar. You have to apply the same formula. B part, xt is equal to e raised to the power of at u of minus t. Again, a is given to be greater than 0. You have to find the Fourier transform of xt. So take 3 minutes should be fine now for this. Take
Yes,
3
ma'am.
minutes and
And
then tell me
first,
answer.
can you scroll it up a little bit once?
You want the formula for the Fourier transform?
Yeah, yeah.
Okay, I will
The
write it here. Now start solving.
got it, ma'am.
Ma'am, is this 1 by a minus j omega?
Yes, yes, that's correct. Should I start solving or you need one more minute? Others? All right. Okay, so Nali got the same. Yes, that's correct. All right, now I will start solving. So we have this formula. This is the signal given to me, and this is the Fourier transform formula. I just have to plug in this xt over here. So let us do it. X of j omega is equal to limits integration minus infinity to infinity e raised to the power of at u of minus t e raised to the power of minus j omega t dt. Now we have u minus t here. So this is 1 between 0 to minus infinity, and in the positive side it is 0. So the limits will become minus infinity to 0. This is clear now that y limit will be minus infinity to 0.
Yes, ma'am.
All right. Again, we will take these e terms together and then compute the integral. So e raised to the power of a minus j omega into t dt. If we integrate it, we will get the exponential back and this factor will be divided. Limits minus infinity to 0. When I plug in t equal to 0, it is e raised to the power of 0. E raised to the power of 0 is 1, and the denominator, then I plug in t equal to minus infinity. So e raised to the power of minus infinity will be 0. So this is what I have as the Fourier transform. 1 upon a minus j omega. So e raised to the power of at u of minus t has the Fourier transform 1 upon a minus j omega. This is clear to everyone.
Yes, ma'am.
Now in part C, now you have to combine both of these things. So part C is the following. Xt is equal to e raised to the power of minus a mod t. You have to find the Fourier transform of xt. So first let us remove this modulus. So e raised to the power of minus a mod t is equal to, for t greater than equal to 0, what will this be equal to? Can someone tell me?
e to the power minus 80.
E to the power of minus 80, t is positive, so mod will open with positive. Now we have t less than 0. So what will happen to this in this case?
E to the power 80.
Yes, e raised to the power of minus a multiplied by minus t. That is how we open the mod with the negative sign. That becomes e raised to the power of 80.
Ma'am, but we get the different value at e is equals to 0.
At e equal to,
0.
e is a constant now.
Sorry, ma'am. T is equals to 0.
If we put in t equal to 0, it will be e raised to the power of 0 in both the cases, which will be 1.
1.
So should we write it explicitly or should we include with the positive?
We can include it anywhere. If we use this for t equal to 0, this one, I will get e raised to the power of minus a into 0, which is e raised to the power of 0, which is 1. If I do it here, e raised to the power of a into 0, e raised to the power of 0, which is again 1.
Okay, ma'am.
Got it now?
Yes, ma'am.
Okay. Now let us write, we have opened the modulus, but we want to write it in terms of ut, so that we can use our previous results. So for t greater than equal to 0, I can write e raised to the power of minus at into ut. Can we do that?
Yes, ma'am.
Because t greater than equal to 0, ut for t greater than equal to 0 is 1. So I will get the same thing. Now for t less than 0, I can write e raised to the power of at into u of minus t. Ut is 1 for t greater than equal to 0, 0 otherwise. U minus t is 1 for t less than equal to 0 and 0 otherwise. That is why we have written this. Is this clear how we wrote xt like this? Others also? Is it
Yes,
clear?
ma'am.
Okay. Now if we look at part A and part B, so this part B is over here. This thing, we have it here. Now let us go to part A. It was e raised to the power of minus 80 ut, and here we have this. So by the property of linearity of Fourier transform, I can say, do you want me to write down the property of linearity? Class, do you want me to write down the property of linearity?
Yes, ma'am.
Okay. So suppose I have this, I will take f and g. Okay. So ft has a Fourier transform f of j omega. G of t has a Fourier transform g of j omega. So a times ft plus b times gt will have the Fourier transform a times the Fourier transform of ft plus b times the Fourier transform of gt. This is the property of linearity. Now we will be using this property for part C. So now we know the Fourier transform of this. We know the Fourier transform of this. So we will simply add their Fourier transforms. Is this clear? All right. So x j omega, the first one had 1 upon a plus j omega, plus the second one had 1 upon A minus j omega. Now let us simplify this. So this we get in numerator by the cross multiplication, and here we have this. Now we have some cancellations here. If you see, this and this gets cancelled. So I have 2 times A, and in the denominator, A plus B into A minus B, that identity. So A square minus B square, j omega whole square will become negative. So that will make it plus. So I have A square plus omega square. This is clear? So we have the Fourier transform of e raised to the power of minus a mod t as 2a upon a square plus omega square. Is this clear?
Yes, ma'am.
Now the second question is also easy. I have divided into 3 parts. So it is about the Fourier transform of impulse function. So part A, xt is equal to delta t. You have to find the Fourier transform of xt. So let me, okay. We will be using the Fourier transform formula here again. So take 2 minutes and tell me what will this be equal to. You have to substitute this over here and then use the property of impulse function.
It will be become 1.
Yes,
Actually,
that's correct. It will be 1. Let us see. So integration minus infinity to infinity, xt is replaced by delta t e raised to the power of minus j omega t dt. By the property of impulse, we know that this whole integral will be equal to e raised to the power of minus j omega into 0, t equal to 0. So that will give me 1. E raised to the power of 0 is 1. So we get 1. Is this clear, class?
No, ma'am.
What is it that you didn't understand?
That how we wrote here 0 e to the power j omega into 0.
Okay. Suppose I have some function zt. I have impulse delta of t plus t naught dt. Do you remember any such property that you studied in the beginning? And a
Yes,
property
ma'am.
of impulse?
Got
So
it.
tell me, what is this equal to?
Z of t naught.
No, not z of t naught. So what we do is, here I have t plus t naught. I will put t plus t naught equal to 0. This gives me t is equal to minus t naught. So it will be equal to z of minus t naught. Is this clear, Sonali?
Yes, ma'am. Now it's clear.
So we did the same thing here. Delta t, t equal to 0. I substituted t equal to 0 in this function. I get this, hence this and this. Clear?
Yes, ma'am.
Okay, B part, x of t is equal to delta t plus t naught. Tell me the Fourier transform of this. I've written the Fourier transform equation. Tell me the answer. Take 2 minutes.
e to the power j omega t naught,
E to the power minus j omega t naught.
not minus.
Abul,
Minus
Abul,
t.
correct. It will be plus only. I will show you. Just give me a minute.
In place of t, we have to put minus t naught, na?
Hmm. So this same property we will use. The same property of impulse. So in the Fourier transform equation, I will substitute x of t, that is delta of t plus t naught e raised to the power of minus j omega t dt. I put t plus t naught equal to 0. That gives me t is equal to minus t naught. So my integral will become e raised to the power of minus j omega minus t naught. That will become e raised to the power of j omega t naught. Is this clear?
Yes, ma'am.
We can, also see this by the shifting property. So if you remember the time shift property, if um, okay, if xt has the Fourier transform x of j omega, then x of t plus or minus t naught will have the Fourier transform j omega t naught x of j omega. This is the time shift property. Are you able to recall this? So, if we use the same property, so for delta t, we had the Fourier transform to be 1, right? Now I'm shifting it. I'm making it delta of t plus t naught. Delta t had the Fourier transform 1. Delta of t plus t naught will have this same term e raised to the power of j omega t naught into 1, which is j omega t naught. Did you understand this? Jay, Uma,
Yes, ma'am.
Sonali.
Yes, ma'am.
And who is this fourth person? Swastika. Okay. So now third part is also very similar. I will just give you 1 minute for that. Xt is equal to delta of t minus t naught. Tell me the Fourier transform of this.
It will be
I
e to the
think it
power
should be
minus
e to the power minus j omega
j
t naught.
omega t.
Yes, that's correct. It will be e raised to the power of minus j omega t naught. We can either use this property or the Fourier transform equation. So let us first see by property. Delta t had 1. So delta of t minus t naught will have e raised to the power of minus j omega t naught into 1, which is e raised to the power of minus j omega t naught. And we can get it by the Fourier transform integral also. Now, third question. So, xt has a Fourier transform given by x of j omega. Yt has a Fourier transform given by y of j omega. Yt is equal to x of 1 minus t plus x of minus 1 minus t. You have to determine y of j omega in terms of x of j omega. So here two properties you will, or rather three you will be using. Properties used. First one, linearity, for the addition of these two. Then time shift you will use. Time shift property and also time reversal property. So these three properties you will be using. Linearity property I had wrote down. Time shift also I wrote down. I can copy paste it once more for you. Yeah, this one. This is the linearity property and this is the time shift property. And time reversal, let me just write it here. So if xt has the Fourier transform x of j omega, x of minus t will have x of minus j omega. So these are the three properties that you have to use. I have written them here. You have to tell me y of j omega in terms of x of j omega. I will give you 3 minutes. So start solving. You understood the question now? Class, did you understand the question?
Yes, ma'am.
Okay,
Yes,
now
ma'am.
start solving now.
Can I tell the answer, ma'am?
Yes, yes.
Uh, 2 cos x minus j omega.
2 cos omega x minus j
Yeah,
omega.
yeah. 2 cos omega.
Yes,
X
very
minus
good.
j
That's
omega.
correct. Yes.
Yes, ma'am. I have also got e to the power j omega plus e to the power minus j omega. When we multiply, when we divide by 2 and multiply by 2, we can get 2 cos j omega.
2 cos j omega x minus j omega. Okay, now I will also start solving. So let us first take the first term. So x of minus t plus 1. I start from here. I do time shift first. So time shift will give me e raised to the power of j omega x of j omega. Plus 1 is there now. So that. Next, I will do reversal. So in reversal, I will replace omega by minus omega. So minus j omega x of minus j omega. This is clear to everyone. Sonali, Swastika, Uma, is that clear?
Yes, ma'am.
Yes, ma'am.
All right, we can, do it other way also. Here I did shifting first. What if I do scaling first? So if I do scaling first, I will just take this minus sign common so that my shifting number is divided by scaling number. So now I will do reversal first. So it will be x of minus j omega. Next, I will do time shift, and this time it is minus 1 because we took the minus sign common. So it will be e raised to the power of minus j omega x of minus j omega. So whether you do scaling first or you do shifting first, you are going to get the same one. So this was for this first term. Is this clear? Now the next is x of minus 1 minus t. So x of minus t minus 1. I will do shifting first. So I will have minus 1 e raised to the minus 1 is there. So e raised to the power of j omega. E raised to the power of minus j omega into x of j omega. Now minus t, that means reversal. So omega will be replaced by minus omega. So e raised to the power of j omega x of minus j omega. Now I will add these two because they were added in the signal. So y of j omega is equal to e raised to the power of minus j omega into x of minus j omega plus e raised to the power of j omega x of minus j omega. I take e raised to the power of minus j omega common. So I get this. Now I will multiply and divide by 2 so that I could convert it into cos. This thing becomes cos omega. So this is equal to 2 times cos omega x of minus j omega. Just the answer that you got. Is this clear? Okay, now next question is very similar to this. So you have to tell me the answer. X of t has a Fourier transform given by x of j omega. Y of t has a Fourier transform given by y of j omega. Xt is equal to e raised to the power of minus 2 mod t. So if you remember, we determined the Fourier transform for e raised to the power of minus a mod t. So that you will have to use here. Yt is equal to x of 2t minus 3. You have to determine y of j omega. So first you will use the properties here and get y of j omega in terms of x of j omega. Once you get that, then you will substitute x of j omega with the Fourier transform of this and you will finally get your answer. Start solving. 5 minutes would be fine or 3 minutes.
3 minutes, I'm fine.
All right, then take 3 minutes and then tell me the answer. Start solving. Here you will be using two properties, time shifting and time scaling. Last time's up. Hasn't
Yeah.
even got the answer.
Yeah.
What is it, Jay?
I think I have. I'm not sure, but I got 8 e to the power minus j 3 omega by 2 divided by 16 plus omega square.
Yes, yes, that's absolutely correct.
I
Okay.
have got same, man.
Okay, very good.
I was confused in the sign of e to the power minus j.
Hmm.
It is plus or not.
Okay, so now let us start solving. First, we will find y of j omega in terms of x of j omega, then we will substitute. So I have x of 2t minus 3. I will do shifting first. So this gives me e raised to the power of minus j 3 omega x of j omega according to the property of time shifting. Now I will use time scaling, the one written in blue. So 1 upon 2, which is mod c. Now I have to replace this omega, wherever it is there by omega by 2. So I have half e raised to the power of minus j 3 omega by 2 x of j omega by 2. This is equal to y of j omega. Xt is given to be e raised to the power of minus 2 mod t. We found out the Fourier transform of e raised to the power of minus a mod t as 2a upon a square plus omega square. So we will be using the same thing here. A is 2 here. So I get 4 upon 2 square, which is 4 plus omega square. So now I have x of j omega. I need to substitute that over here. So let us do it. Y of j omega is half e raised to the power of minus j 3 omega by 2 multiplied by. So this was x of j omega. I have to replace omega by 2 because of this omega by 2 over here. So I will have 4 upon 4 plus omega by 2 whole square. Now we will very quickly simplify it. So half e raised to the power of minus j 3 omega by 2. I get 4 upon 4 plus omega square by 4, which will give me this 4 will come, this 4 will come in numerator. It will get cancelled by 2. So in numerator, I have 8 e raised to the power of minus j 3 omega by 2, and this multiplied with this will give me 16. So I have omega square plus 16. So this is the final answer. Everyone understood how we got it? Uma, Swastika, Sonali, Aniket, Abu, you got it?
Ma'am, in xj omega, why do you are changing from omega to omega by 2?
Okay, let us come back to this. In the question, yt is given as x of 2t minus 3. We
Yes,
want to
ma'am.
find y of j omega, right? So what we did, This was like y of t. So first we found out y of j omega in terms of x of j omega. So let us see how did we do that. Yeah, sorry. So over here, this is given to me. So I will do time shifting first. Shift by -3. When I use the time shift property, I get this. Is this clear? Sonali, is this clear?
Yes, ma'am.
So this I got by time shifting. This is the time shifting property. Now
Yes, ma'am.
I will use time scaling property next. Scaling by half. This is the time scaling property. X of ct, x is scaled by ct, then the Fourier transform is 1 upon mod c x of j omega by c. So I use that property over here. So c was 2 here. So 1 upon 2, and everywhere else omega will be replaced by omega by 2. So in this, omega will be replaced by omega by 2. And this is what I get as y of j omega in terms of x of j omega. Is this clear?
Yes, ma'am. Sorry, ma'am, but I forget that formula. That's why I didn't get it.
Now you understood now.
Yes, ma'am.
We had this x of j omega from our calculation in the first question. So we just replaced this x of j omega over here by omega by 2 and these factors. Clear now?
Yes, ma'am.
Okay, let us move to the next question. It is based on the property of duality. So the question is 1 upon a plus jt. You have to find the Fourier transform of this.
Ma'am, I had a doubt from Fourier series. Can I ask here?
Maybe you can ask in the end. First, let's complete week 9 problems.
Okay, ma'am.
Okay, thank you. So I will write down the duality property here and you try and solve. So if x of t has a Fourier transform capital X of j omega, then capital X j that is in this, omega is replaced by t, then what will be the Fourier transform? That will be 2 pi times small x of minus j omega, that is, in this one we will replace it by minus j omega. T will be replaced. So this is the duality property. Now tell me what will be the Fourier transform of this one. Take 3 minutes. Start solving. This was something similar was there in first question also. Try to relate with that and see if you get the answer. Did anyone get the answer? Class, did anyone get the answer?
Ma'am, I think it is 2 pi e to the power a omega u of minus omega.
Yes, yes, that's absolutely correct. So now let me start solving. Everyone else, please pay attention. So in the first question, we had xt is equal to e raised to the power of minus 80 ut. We computed its Fourier transform to be 1 upon a plus j omega. So now you see this and this, they are like similar. Instead of t, there is omega. So we will use the property of duality here. So 1 upon a plus jt will have the Fourier transform 2 pi e raised to the power of minus a, and t will be replaced by minus omega u of minus omega. T is replaced by u of by minus omega. So I get 2 pi e raised to the power of a omega u of minus omega. This is the Fourier transform for this. Did you understand this? We just simply use the property of duality here. Sonali, did you understand?
Ma'am,
Yes,
in the
ma'am.
question, was it x of t or x of jt?
In the question, in the fifth question, I have 1
Yes.
upon a plus jt. And I want to find the Fourier transform for this.
Yes, but this given 1 by a plus jt, is it x of jt or x of t?
Are you asking with respect to property?
No, 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 no. I'm asking the function, the domain of the function. Is it jt or t?
Basically, you can call it as xt.
Okay.
This is a continuous time function. Xt, you want to find the Fourier transform. Sonali, did you understand?
Yes, ma'am.
Okay, everyone understood now. We just simply use this property over here.
Yes, ma'am, understood.
Okay, now, so this question involves sync. So in week 9 revision, we computed the Fourier transform of sync. So that will be used in this question. So xt is equal to sync 500t plus sync 800t. You have to tell me the value of Fourier transform at omega equal to 0. Is the question clear?
Yes, ma'am.
So let me solve a little bit and give you some idea. Then you can solve the next steps. You can do the next steps. So now I want to tell you that if we have this function a rect p by tau, then it will have a Fourier transform given by a tau sync omega by 2 pi tau. Basically, a tau sync f tau. And we are dealing with angular frequency and not linear frequency, so omega by 2 pi. Now I have this sink in frequency. We want it in time, so let us use the property of duality. So A tau sink T tau by 2 pi will have the Fourier transform 2 pi into A rect of minus omega by tau, which is 2 pi A rect of omega by tau, because rect is an even function. And how does rect look like? This rect A T by tau, this has this amplitude, and tau by 2 minus tau by 2. This is how A rect T by tau looks like. This we discussed in the very initial weeks, and in the last week we discussed these Fourier transforms. So now in question, let us expand sink. So let us take first sink 500T. This sink 500T, I took it. So I can write it as sink 500 pi T, sorry, sine, not sink, sine 500 pi T upon 500 pi T. This is just by the definition of the sink function. Sine theta, sink theta is equal to sine pi theta upon pi theta. So that is what I have used. Now let us try and draw its Fourier transform, which we will use this relation for this drawing this. Sink 500T, if we consider this and compare it with this, then let us try to find tau and A by comparing these two. So tau by 2 pi is equal to 500, or we can say tau is 2 pi into 500, and a tau over here is 1. So that means A is equal to 1 upon tau. And the Fourier transform of sink 500T will be equal to 2 pi, and A is 1 upon tau. So upon tau rect of omega by tau. This is clear until this?
Yes, ma'am.
Sonali, Jay, Swastika. Swastika, is it clear?
Ma'am, please repeat once again.
From the starting?
Yes, ma'am.
Okay. So this question is clear now, that xt is given and you want to find Fourier transform at omega equal to 0. This
Yes,
is clear. Now, this the Fourier transform of the function a rect t by tau is a tau sink f tau. F is omega by 2 pi. So this is what we have. We discussed this in the summary. And professor also discussed. We compute when we were talking about uncertainty, then we computed now Fourier transform of rect. So this is what we have as the Fourier transform pair. Okay. Is this clear?
Yes, ma'am.
Now, we can represent a rect t by tau like this graphically, like this. Is this clear?
Yes, ma'am.
Now, what I did was I used the property of duality, because here sync is in frequency domain and here sync is in time. So I'll have to use duality. So by duality property, I took this, I replaced omega by t and 2 pi x of minus omega. So this is what I get when I use duality.
Yes, ma'am. Got it.
Now we have taken this first term, sync 500t. So there is this sync 500t. Sync 500t can be written as sine pi theta upon pi theta. This is clear.
Yes, ma'am.
Now what I'm trying to do next is I want to write the Fourier transform of sync 500t. So for that I will be using this relation.
Okay. Yeah, ma'am. Got it.
So we will compare this sync 500t with this. So for when we compare them, then I get that tau by 2 pi is equal to 500. Is this clear?
Yes, ma'am.
So now I have the value of tau. Now let us look at the amplitude. So amplitude is 1
One.
and here amplitude is a tau. So that means a has to be equal to 1 upon tau.
Yes, ma'am.
So that is what we have here, a and tau. So now that we have a and tau, let us write this. Is this clear?
Yes, ma'am.
So now 2 pi comes as it is. A was equal to 1 upon tau from here. So tau in division. Is this clear?
Yes, ma'am.
Now simply rect omega by tau. So this is what we have as the Fourier transform. Is this clear?
Yes, ma'am. Got it.
Now let us draw it. So in rect t by tau, it is minus tau by 2 to tau by 2. So here also it will be minus tau by 2 to tau by 2. Tau is equal to 500 into 2 pi. Tau by 2 will be 500 pi. So here I have 500 pi. Here I have minus tau by 2. So minus 500 pi. Now let us try and write the amplitude. So it is 2 pi by tau, which is 2 pi. Tau is 2 pi into 500. So the amplitude comes out to be 1 by 500. Is this clear?
Yes, ma'am.
It is clear to others also, Jay, Sonali, Swastika, Abu.
Yes, ma'am.
Okay, so this we did for sync 500t. You need to tell me what will it be for the second term, that is sync 800t. You have to tell me this waveform. So sync 800t, tell me what will I get?
In the amplitude 1 by 800 and in the domain it will be minus 800 pi to 800 pi.
Yes, that's absolutely correct. Others also try. You want to try or should I explain?
Yes, ma'am. Same.
What?
The amplitude will be 1 by 800 and a minus 800 pi to 800.
Others also understood now?
Yes, ma'am.
Yes, ma'am.
Okay. So let us draw that over here. Eight hundred pi minus 800 pi and 1 upon 800. Now xt was equal to addition of these two. So in Fourier transform, by property of linearity, it will be addition of these two waveforms, right? Is this clear?
Yes, ma'am.
Now when we add, let us see what waveform do we finally get for xt? This is x of j omega. This is omega. So we will get something like this. Between minus 800 pi to minus 500 pi, only this thing will come. So this will stay 1 by 800. Similarly, after 500 pi till 800 pi, it will be 1 by 800 only. So that we have over here. And then in between 500 pi, minus 500 to 500 pi, both of these will be, they will get added. So 1 upon 500 plus 1 upon 800 will be,
13 upon 4000.
yes. So here it will be 1 by 800. This amplitude I'm talking about, plus 1 by 500. And this will be 13 by 4000. Is this clear, the addition?
Yes, ma'am.
Sonali, Jay, Swastika, is it clear?
Yes, ma'am.
Okay. So now in the question, we were asked to find the value of Fourier transform at omega equal to 0. Omega equal to 0 is over here, which is 13 by 4000. So x of 0 is 13 by 4000. And if you convert it in decimals, then it is 0.00325. So is this clear?
Yes, ma'am.
Yes, ma'am, it is clear.
I actually had one more question. So would you like to try it as homework?
Yes.
Ma'am.
I will give you some hints, then you try to solve, okay? It is similar to this sync calculation that we did here. So xt is equal to integration minus infinity to infinity sine of 3 tau upon tau sine of t minus tau upon t minus tau d tau. You have to simplify xt. And these are the four options. Pi sine t by t, pi sine 3t by pi t, pi sine t by pi t, pi sine 3t by t. So is the question clear?
Yes, ma'am.
Now I want you to closely observe this xt. And I am writing the convolution equation here. So x1t convolved with x2 of t is equal to x1 tau x2 t minus tau d tau. So now looking at these two equations, can you tell me what will xt be?
xt will be x1t convolved with x2t.
Yes, and this is x1t, this is x2 t minus tau.
x1t will be sync function and x2t will be also sync function.
Yes, yes. So xt in the question is actually equal to sine 3t divided by t convolved with sine of t divided by t. Is everyone able to see this?
Yes, ma'am.
Jay, Sonali, Swastika, Aniket, are you able to see this?
Yes, ma'am.
Yes, ma'am.
So now you have a convolution over here. what you can do is you will convert this sine t by t form in sinc. And then once you get the sinc form, you will go to frequency domain. You will have the multiplication of two rectangular signals. And when you multiply now, so you will kind of end up getting something very similar to this. So is the approach clear what to do?
Yes, ma'am.
Convert both to sinc, find Fourier transforms, multiply them, then you will get something simplified and then convert it back to time and then compute the inverse Fourier transform. So these are the steps you have to do. So you try and solve, and maybe I will post the answer in the group by next Saturday or Sunday. Is that fine?
Yes, ma'am.
And you can also try and not post the solution, but just tell me the option that you are getting. Is that fine?
Yeah, ma'am.
All right. So that is what I had to discuss. And Aniket had some doubt. So if
Yeah,
any
ma'am.
and if anyone else has any doubt, then please ask, or we can move to Aniket's doubt. From today's session, does anyone have any doubt? Okay, then thank you for joining. Have a great day. Yes, and Aniket, ask your doubt.
Ma'am, can we, like for unit step function, can we find the value of unit step at t equal to 0 using Fourier series? Like, will it be half if we calculate?
See, first of all, if we don't move into Fourier series, then ut, when we define it, then we say that ut is equal to 1 for t greater than equal to 0. Do you recall Gibbs phenomena?
Yes, ma'am.
So if we use the Gibbs phenomena now, and when we have to use the value of ut at t equal to 0, then we kind of, take the value of ut before t equal to 0, then value of ut after t equal to 0, and we just average them out. So
No, no,
for
ma'am. I know
calculation,
this. I know this, but the thing is, from Dirichlet condition, the Fourier series will converge to the average value, right? That's from where that's the thing from where the Gibbs phenomena come, and
but
I want to know if there is some way to prove this.
okay. See, first of all, ut is not a periodic signal now.
Yes, ma'am.
So can we apply Fourier series if ut is not periodic?
I don't know, ma'am.
See, as far as I recall, now Fourier series is for periodic signals only.
But for in the during the Fourier transform lectures, professor said that we can also let that time period to go to infinity. Then it will be a Fourier series for a aperiodic signal.
Yes, that is how we move to Fourier transform actually. So if I think in week 10, na professor has calculated Fourier transform of ut.
Okay, okay. But was there like he also calculated the Gibbs phenomena there?
I don't think he did.
Okay, maybe I will try. Then I will let you know if I can come up with something.
Okay. And you can also mail to Vishal sir or professor.
Okay, ma'am.
Okay, so can we close?
Yes, ma'am.
Thank you everyone for joining. Have a great day. And please try to solve
Seventh question.
Bye bye.
Thank you, ma'am.
Yeah. Okay, ma'am.
Thank you, ma'am.